Okay, well, we have three equations to solve. First one, I think most everybody did this correct. I think maybe there's some trouble in some cases. Well, equations talking down the thing. You use a distributive law. Now, I recommend when you write these things out in a note, just make a note, distributive law, even D period L period, or even DL. Okay. Show what you did, just so you know what it means, and I have at least an outside chance of interpreting about what we're looking. Okay. That's the first thing you forget. I hope you're writing these things out because you're not going to reinforce it as well otherwise. Okay, anyhow, we apply the distributive law here. It says 4 times 3x and then minus 4 times 7, which is 12x minus 3a. Then 2 times 5x plus 2 times 9 is 10x plus 18 minus 8. Okay, nothing to that. But let's go ahead and simplify right hand side a little bit upwards to do some arithmetic. 18 minus 8 is 10, as I very much remember. So here we have it. And now I'll do it in 2 steps. It's a little note. It'll be easier to see if you happen to be looking at the video. You might not have any need for you to do all this. But add to both sides, you got 12x minus 28 minus 10. It's 10x. I could put it as easy. Gremlins must be operating. Zoom phone. Hang on a minute. Make sure the camera's what I think it is. Yeah, I think it is. Okay. Don't know what that was. Zoom might have just had a hiccup. It started recording again, which was a good thing. Never stopped it. Okay. I always it's close for little. Okay, now here's where it stops. Nobody did this by the official means, although one person did put everything over common denominator, probably got a good solution. Okay. And similar down here, I'm not even sure, I didn't look to see if anybody actually did the common denominator right. So this totally unnecessary to do that. You got x over 5 plus 3 equals x over 3 plus 5. Now, yeah, you do have a common denominator of 15, so you can multiply this one by 3 over 3. Multiply this one by 5 over 5, multiply here by 5 over 5, multiply here by 3 over 3, and you still have a denominator. Okay? Why deal with a fraction when you don't have to? Now, we'll observe a lot of people have a lot of problems with this, but you know, they're kind of clear. And people stop before they got to questions. Some people stop before they got to questions like this. Okay? So if you're going to stop and think that you're going to be able to do all the rest of it, you're tired of doing it, you know how to do it and everything, better look down and make sure there's nothing there that you don't know how to do and do it. Okay? That's just good advice. Okay, so here we're going to multiply both sides by the common denominator. So we multiply by the common denominator. 15 times x over 5. Well, I'm going to multiply both sides. Just to emphasize that that's what we do. A lot of people just multiply this by 15 and multiply this by 15 and not multiply this by 15. Okay? You don't want to do that. You want to multiply both sides. And you probably ought to write multiply both sides by common denominator. Again, just to help lock it into your brain, that's the operation that's legal. Okay, so use a distributive law. 15 times x over 5 plus 15 times 3 equals 15 times x over 3 plus 15 times 5. Okay, so that's like 15 over 1 times x over 5. It could be 15 over 5 times x over 1. You'd have the same numerator denominator. So you can divide the 5 into 15 and you get 3x. And you divide 3 into 15, get 5x. Now that's a lot simpler than trying to put everything over common denominator. You clear the fractions. You don't have to use fractions when you're solving equations. You can get rid of them and get everything up here, which is easier to work with. Okay. So now I'm just going to, you know what the steps are. We're going to subtract 5x from both sides, subtract 45 from both sides. We're going to get 2x equals 30, so x equals 15. Then we check that. Especially since this is something we're not typically, we're going to check here as well. Yeah, you put 19 in here. 3 times 19 is 57. 57 minus 7 is 54 times 50 is 200. 5 times 9 is 95. Add 9, you get 104. 2 times 104 is 108. You subtract 8. Get 2. Okay. Same both ways. So you want to write that out. Especially if you're doing something you're not 99% sure of. That way, if you're doing something wrong, you won't keep doing it wrong. You'll fix it, or you'll ask the question if you can't figure out how to fix it. That's the way you'll learn. Okay, well, we checked. So, 15 over 5 plus 3, is that equal? 15 over 3 plus 5, well, yeah. We get 5 plus 3 equals, sorry. Possible I made a mistake. Yeah, it's negative 2x. It should be negative 15. Look at that. It wasn't going to work. Okay. So again, I pretended to make a mistake. Okay. Actually, I made it. That's careless with the sign. We should have a minus 15 and a minus 15. So we get minus 2 plus 3. Sorry, it's minus 3 plus 3. . Cascading errors, -3 plus 3 equals -5 plus 5. Zero equals 0, and that checks the box. Okay. So you see, I'm working along and I'm prone to get careless with signs. The check is going to show me. I could have gone through life with this was 15 if I hadn't checked. That would have been, I won't say tragic, it would have been very sad. Okay, well, here we have. Now, the last one, we're going to use the same strategy, x over x plus 3 plus, equals 2 plus 5 over x plus 3. That looks kind of scary when you first look at it, the first time you see one of these, especially if you haven't studied the text and the example as well. Okay. Go through by the seat of your pants, which a lot of people do. It seems like it's faster. Okay, probably is, but they can be what it is. People do that. Okay, so we multiply by common denominator. It's x plus 3. So we do x plus 3 multiplied by x over x plus 3 equals x plus 3 times 2 plus 5 over x plus 3 on both sides by x plus 3. Then this x plus 3 divides this one, leaves us x. And this x plus 3 multiplies 2. So we get x plus 3 times 2 plus x plus 3 times 5 over x plus, proving on my stuff over here. Can you see what I did? I can rewrite it bigger. Somebody like to rewrite it bigger. I'll rewrite it. X equals x plus 3 times 2 plus 3 times 2 plus x plus 3 times 5 over x plus. Okay. And you don't see this next. There's really just one. Everybody's that. All right. Now we've got to do the work here. We get x equals 2x plus 6, x times 2, 2x times 2, 6, plus 5, because x plus 3 divides x plus 3. Now we have an easy equation to solve. Very easy. First we have 65, we get x equals 2x plus 11. Then we subtract 2x from both sides. You're going to need to solve that. Got it? We'll do it again. Okay. Multiply both sides by 8, or we can use a common denominator. I'll go ahead and use the common denominator. It's kind of quick. doesn't hurt us to look at a couple of fractions. So this gives us -11/8. Uh-oh. This is not -11/8. Darn, look at this. Numerator is negative, denominator is negative, it's 11/8, not -11/8. Okay. Do better than I do with signs. Anyhow, this equals 11/8 on both sides, and that checks. And you want to check these especially, because there are a number of steps, and it's really easy to mess one up. And it's really easy to continue to do things wrong. But if you're checking as you go, you'll correct that. Okay. Well, let's pause for a minute. All right, now people didn't do well with this problem because, as I've said, I think proportionality is an idea that just gets left out of the curriculum. And it's actually a pretty easy idea. And I find this inexplicable, but I also read many years ago that it's a difficult thing to teach. Not sure what's difficult about it, but let's try to work through it, okay? And it's quite important. Okay, well. Comes down to this simple thing. Go with your fingers, what goes there? X increases by what factor? Yeah, before you dropped your pen, that was gonna be right. What do you think? What do you think? What factor? What factor mean? Okay, now, couple you voted, thank you. Okay. Well, factor is something that multiplies something. What would you multiply X by? What would you multiply 2 by to get 6? Can anybody tell me? Should be obvious. You multiply 2 by 3 to get 6. Okay? By factor of 3. That's what it means. That's the factor by which X increases. Okay? Right. Right. Y is directly proportional to X. Y also increases by factor 3. So the new Y must be what? You write the number down on your paper and circle it where I can find it. big enough that I can see it without having to move closer. Okay, about half and half. Y increases by a factor of 3. Is the original value of Y? Can you show me the figure? Yeah. I understand that. The original Y was 12, right? Y was 12 when X equals 2. Okay? Y is 12 when X equals 2. So what's Y when X equals 6? Well, X gets 3 times as big, right? Increases by a factor of 3 in other words. Original Y was 12. Okay, if you were confident of your first answer, write down the answer this time. Versus ever since your first, okay? But I've never paid much attention. You know, it's ways into algebra before okay, term is something you add, factor is something you multiply. All right. So it's possible to get everything right without really knowing what the words term and factor. Okay. Now, if algebra is taught the way it ought to be, you ought to have a vocabulary as well as be able to manipulate symbols again, so you retain them and so you do it right. Too low. Does that halfway make sense? Okay. That should make complete sense. When you do proportionality or direct proportionality, you want to think in terms of this terminology. You probably want to write out several problems. Maybe abbreviating the words with all the logic and all the reasoning and the terminology so that you'll get used to it. You probably want to spread that over a couple of days because it takes a while to get used to terminology. You do it the night before it's due. Not going to retain it as well. Do it. You know, it's due 2 days. I'd say do some of it today, and then just break the ice, get used to the terminology, let it sink in overnight. Then, well, okay. Now, there's more to it. There's a method you can use to solve a problem without understanding a thing. You want to start understanding what works. So I can, there's a method, just a little bit of space here, I think. Okay. It's just abbreviation. Y is directly proportional to X means among other things. It means this, whatever you gotta multiply x by, you gotta multiply y by. They increase by the same factor, or they change by the same factor, could be a decrease. Okay, whether proportional x though also means y equals kx for some fixed value of k. In this case, y equals 12 and x equals 2. So 12 equals k multiplied by 2. That's easy to solve. K equals 6. Um, y equals 6x. Y equals kx becomes y equals 6x. Okay? It's another way of looking at it. Y is 6 times as big as x, and y's got to stay 6 times as big as x. If it's 6 times as big as x, then if x is 6, 6 times that is 36. There's your answer. Okay? But this is a way to formalize it with equations. Y equals 6x. Thus, x equals 6. Y equals 6 times 6 is 36. You can also say the ratio of y to x is 6. Okay. 12 over 2 equals 6. 36 over 6 equals 6. That is y1 over x1 equals y2 over x2. Here's y1, here's x1, here's y2, here's x2. There are other ways to write this out. But we're going to come down to this method here. Now, let's try this. I should have really said y is directly proportional to x. It's more traditional way to write it. It's okay either way. But y is directly proportional to x. What's y when x equals 14? And most of you are having some trouble getting started. Let's say follow this. And it starts with the assumption that y equals kx and everything else falls right in your lap. So see what, imitate the steps I did. You have new numbers, but they're not difficult. You can do this. And so you write out some words. Direct proportionality means y equals kx. And you probably also want to write out fixed k because this is something people lose track of between doing the assignment by rote and then having to do it on a test. Okay. Write out what you're doing. Okay, so the timer on board. So we got y equals k. Now, y equals 20. X equals 4. So 20 equals k times 4. How do you solve this for k? You divide both sides by 4, right? This side you just get k, and this side you get 5. But you would usually want to write it k on the left, k equals 5, right? Now, some people have trouble solving this equation. Means you need to go through the steps on the last assignment. Make sure you know what you're doing in every step so you get used to the idea that in a situation like this, you're going to divide both sides by 4. Okay? If you haven't locked in that idea, you need more practice and you need to write things out. All right. Now, most of you have it locked in, but some people had a little trouble solving that. Because we get k equals 5. Now, that's great. What should I do? Here, why did I say then y equals 6x? It's because y equals kx, and we found that k is 6. So instead of y equals kx, no, we can write y equals 6x. Why? Because it's a fixed k. It's a value k that doesn't change. So we get y equals kx becomes y equals 5x. I've written out a little more. I didn't really write it out that way overhead, so it becomes, and it might have been easy, but the numbers came out unfortunately. There are a couple of 6s floating around here. Might not have been clear why the 6 went there, so it should be clear here where that 5 came from. Now, if x equals, what did I say, 14? Y equals 70. Okay. Now I'm going to recommend a way to check. Your ratio of x values is 7/2. Okay. It's 14/4. That reduces to 7/2. y2/y1 is 70/20, which reduces to 7/2. Same ratio, so with checks. I do recommend right about like this. There will be another way to solve this. You could say x increases by a factor of 7/2. X goes from 4 to 14, 14 over 2 is 7/2. So you take 7/2 of your y value, which is 20. 7/2 is 27. Okay, a lot of ways to see this, and it's kind of important to see all these ways because there are a lot of things in mathematics you got to think about that involve these kinds of ratios and proportionalities. And if you can't think in these terms, you're less likely to successfully solve problems you're likely to see on the test. Okay. And less likely than in life, think in terms of proportionality. Okay. You know, I'm buying, looking at my deck, I'm buying 8-foot boards and 10-foot boards, 12-foot boards, and so forth. Okay. So what's cheaper? 2 8-foot boards or 1 16-foot board? Well, 16 feet is twice as much as 8 feet, right? So if the 16-foot board is more than twice as expensive as the 8-foot board, I get more board by an 8-foot board. Okay. Now I got to balance that against. You got 2 boards to lay down where you could have one, so you have fewer seams. And even if the 16-foot board's a little more than twice as expensive, it's worth it. I don't have to cut it. I don't have to line up the seams and all that stuff. Okay. But I can think about that. Yeah. You gonna think about that? If you're in that situation, well, you're much more likely to think about it if you understand. Okay. That's just a simple everyday example. I guarantee you, contractors know how to think about proportionality. Okay. At least successful contractors can actually make money doing this stuff. Okay. But that's just again one really simple example of proportionality. Now, let's go to another example. It's a little more complex. Y is directly proportional to x squared. Y actually 15. Okay. Now your first step here was write y equals kx. Is that what you're going to write here? What do you think you ought to write for your proportionality equation? Given this proportionality. Okay, class as a whole got about 60% on this. Okay, which is pretty good. Means the rest of you are going to understand it pretty well when I write it out. Y directly proportional to something means y equals k times that something. If that something is x squared, then you write y equals k x squared. Okay. Then you plug in numbers. Well, y is 8 when x equals 5. they're not going to put x equals y equals 8 with x equals 15. You're going to find out what y goes with x equals 15. These two things go together. Y equals 8 when x equals 5. So we write 8 equals k times 5 squared. So that 8 equals 25k. So that k equals 8 over 25, which equals 0.32. So now y equals 0.32 times x squared. If x equals 15, then y equals 0.32 times 15 squared, which is 0.32 times 225. Now you could have written 8/25, 25 would have gone into 225, 9 times 10 9, 72. But you could easily multiply this, use your calculator if you need to, because a lot of proportionalities, you don't have a simple way to calculate that in your head. Okay, but you could have used the 8/25. You could have changed 0.32 to 8/25 at any time. The 25 would have gone into the 225 and made it a pretty simple calculation. However, nothing wrong with the calculator, but try to do clever things. It just makes you clever overall. Anybody want to be less clever? Anybody want to be more clever? Most people want to be more clever, right? It's generally beneficial. I try to think of clever ways to do the calculations rather than just pulling out a. Okay. Yeah, don't spend hours trying to be more clever. Just, every time you have a chance to maybe think of something more clever, try to think of it. But don't spend a whole lot of time doing it. Just try to draw your attention to being a little more clever. Okay. There we go. More, and there's variation. I want to get these ideas to you pretty quickly. Now, our check. X2 over X1 is 15 over 5 equals 3. Put the importance to X squared. X2 squared over X1 squared is 15 squared over 5 squared, which is 225 over 25 equals 9. Or we could have just said X2 squared over X1 squared, the same as X2 over X1 squared. We already figured out that X2 over X1 was 3. So we could have just written that this squared is 3 squared, which is 9. We didn't even have to write this out. Okay. And then Y2 over Y1 equals 72 over 8, which equals 9. y2 over y1 equals x2 over x1 quantity squared. Then they try to understand that and do that as a check. Okay, write out the words, write out the idea. Get it into your head so it'll be there when you need it. I can't do an example if you don't have time. I can tell you what an inverse proportionality is. That. Y inversely proportional to X means Y equals K over X. As you'll find out from the open math, this means that when X gets bigger, Y gets smaller. Okay, and you see several examples cases where that might happen. And it's another common proportionality. You have two gears, one with more teeth moves more slowly than one with less teeth. More teeth means more slow. Increase the number of teeth, speed decrease, or the rotational rate. The angular velocity. Okay. So anyway, you get Y equals K over X. I mean, that's all I'm going to say. If you see inversely proportional, you write this out and then do all the same stuff. Okay. You put the values of Y in, then you solve for K. In that case, you're going to multiply by this denominator. One step. Now, you think Y inversely proportional to X squared would be? I'm not going to have time to come around and look because we're almost out of time, but write it down on your paper. Or write down on any old spread. Okay. Well, this is a starting point. Y is inversely proportional to X squared, right? That should be obvious. I think the majority of you either had the right thing back there on the last one or we very close to. Okay. And think about what these things mean. Think about the examples and think about why proportionality is important. I would say it's as essential a skill as you get in mathematics. Allows you to think about things you wouldn't otherwise be able to think about.